launch the analysis. So click on perform analysis here, and you see then in less than 3 seconds their analysis has been performed. Before looking at the results, we'll create some load combinations. So go into result tab, load combination. So this type of load combination is created in the post process, so you don't have to do the calculation again. Enter name, so load combination 1. Load cases, enter dead load, sidewalk load, and moving load, and click on close. Now let's verify the deform shape. Click here on deformation, deform shape. Use the CB combination minimum LCB1, DXYZ for the component. Check undeformed and legend. Deformation value, you can set that to real deformation, and you will have the deform shape here. So if you activate the section, this is what you get for this load combination. Now it's time to let's look at the shear force and the beam diagram. So hide again the section and come back to the initial view by clicking here on initial view. Now we'll select only this face in order to see the beam diagram in this section only. So in the view section here, the selection tool, choose plane selection, X, Z plane, select the first node, and click on close, and activate only these elements. Now you can go in the front view and click on beam in the results tab, beam diagram. So it is in result forces, beam force and moments. Oh no, I will select beam diagram, sorry, beam diagram. For the load case, select moving vol MVL. Now enter MY for the component. You can choose 5 point for the display option and line field. Enter 1 in the scale field. Check contour and legend, and click on apply. And now you have a view of this beam diagram. Lastly, we'll check the influence lines results. So for the moving load, so all the moving load results are in this tab. Click on influence lines reaction. We'll check the lane 1 only. Before doing that, I will activate again all the mesh and come back to initial view. Okay. Result influence line reactions. Lane 1, 1 for the key node, and 1 for scale factor. Check legend and click on OK. And now you can see the influence line. So if you want to set for another node, you can check the number of the nodes, for example, and if you want to set for the node 19, you can, like that, enter 19. Okay. Let's go to the front view to see better this influence line. Now you can animate all that by clicking on animate, apply, check and record, and you will have small animation of your load, moving load on your bridge. Now let's check the displacement. Always for the lane 1, you can close this animation. Okay. The key node enter 15, enter 2 for scale factor to make it a bit bigger and see better what is happening. Legend, check the legend and click on apply. You can go to front view. Now you see at this node the displacement influence line. You can check also the beam force moment for the lane key elements 23. Use 2 for scale factor, my at the part I of the beam, check the legend, click on apply, and this is the influence line for the beam and force moment. Now the last visualization option for the results is the moving load tracer. So click on moving load tracer, then you can go into reactions again. For the case, just use MVmax, MVL, 1 for the key node, 1 for scale factor, check contour, applied force and legend, and click on apply. And you have an overview of this moving load tracer. To view better, I will only activate this part of the beam. Okay. Now let's look at the beam force moment for the moving load tracer. You can enter 28 here, scale factor 1, my, apply. Now you see what is happening on this part of the bridge. Having determined the moving load location by the moving load tracer, we will now examine the method of converting the live load into static load. If we click right min max load to file button of the moving load tracer function, the converted static load is saved in an MCT file. When we execute the MCT file using the MCT command shell in the model file already generated, the static load will be entered in the model. So click here, click on OK, and now you see the results in the text file. Click on File, Exit, and in the main menu, click go in the Tools menu, MCT command shell, and here you can open this file that you just imported. Select a load, static load case, and in the name confirm that this load has been generated. Click on Close and click on Analysis again. Now if you go into the results and you check again the beam diagram, you have the load case here which appeared. You can check for MY, activate the legend, you can apply. You can use solid fill, view better, and now you can see the influence of this load as a static load. And this is all for this tutorial. Thank you very much for watching.